So this one, we're increasing the pressure of the air in the container. We're trying to figure out if the ball goes up or down in the water, or if it doesn't move at all. Let's start it by doing a force balance on it. And we've got two forces of buoyancy, the buoyancy due to the displaced water and the buoyancy due to the displaced air. And those two buoyancies are balanced by the weight of the ball and the air inside of the ball. So if we write this, we'll say for the water, we've got the density of water, rho W times G times VW now, which is the displaced volume of the water. So it's this hemispherical cap at the bottom of the ball which is being displaced, plus the buoyancy force of the air times G times the displaced volume of the air. And the sum of those has got to equal the mass of the ball in the air in the ball times G. The total volume is the sum of the volume of the air and the volume of the water. And I'll make this substitution, and what I come up with, the density of the water times G times the total volume, the volume of the ball, minus the volume of the ball that is exposed to the air, plus the density of the air times G times the volume. So in this equation, the G's fall out. It doesn't matter how much gravity is involved. And what's happening, we're going to increase the pressure of the air, so we'll increase the density of the air. We're going to cram more mass or more number of air molecules into the same volume. So rho A is going to increase. And we want to figure out what happens to VA. And if VA gets bigger, it means that the ball has moved upward. And if VA gets smaller, that means the ball has moved downward. So if I solve for VA, what I come up with, VA is equal to the density of water times the displaced volume minus m divided by the difference in density of water minus the density of air. And I'm increasing rho A, which means I'm decreasing the term in the denominator, which means I'm increasing VA. So by increasing the pressure, increasing the density of the air, I'm increasing the volume of the ball exposed to the air, and as a result, the ball actually floats higher. So correct answer A for this. Increase of VA means VW is smaller, so the portion of the ball actually in the water is reduced.